All right, if you take a look at example 8, this is our first look at a problem with the chain rule that the argument of the original function is a composite function itself. So what I'm looking at here is this is a cosine function, cosine of stuff. And the stuff, tangent of sine of x, is also a composite function. It's not just tangent of x, it's tangent of sine of x. All right, so that's kind of what's happening here is that the overall function is a cosine function, so I'm going to use a cosine derivative in order to differentiate the problem. So, starting off with the cosine function, I know f prime of x is negative sine of the same thing. In this case, the same thing is tangent of sine of x. Then, since it wasn't just cosine of x, I now have to do derivative of the stuff, which is all this red stuff here. And the red stuff is a tangent function, and the derivative of tangent is secant squared of the same thing. So I differentiate this, I'm going to get secant squared of the same thing. But notice the same thing is sine of x, not just x, so then the derivative of sine of x is the sine function, is cosine of x. I keep chaining until I get to the most basic type of function, which is one of my 6 trig functions: sine of x, cosine of x, tangent of x, cotangent of x, secant of x, cosecant of x. There's one of my basics, right? Once I do a basic, I'm done. All right? Tangent of sine of x is not basic, but still tangent's derivative of secant squared of the same thing. But I still have to chain it again because this is not basic. And this is cosine of stuff, it's not cosine of x, so I have to do this chain rule. So again, whatever the first thing is the type of function it is if you're dealing with trig stuff. That's how you do its derivative of the same stuff, derivative of the stuff, derivative of the stuff. Keep going until the most basic type of function is there, and that's when you stop. You've done the derivative enough at that